In lesson 48, we're looking at radical equations. Okay, and our first step when we're solving radical equations is to isolate the radical or get the square root or radical all by itself. So in example 1, I need to add the 2 to the 6 just to move it to the other side. So I'll have the square root of x minus 4 equals, that was plus 2 here to cancel it there, equals an 8. And then, to get rid of the square root, I need to do the opposite, which would be squaring. So I'm going to square both sides of the equation. So I'll have x minus 4 equals 64. And then I'll add 4 just to move it to the other side. So x equals 68. Okay, and then we'll do the same thing on example 2. This time we need to get x plus 4, the square root of x plus 4 by itself. So I'm going to subtract 2 to move it to the other side. So I'll have the square root of x plus 4 equals a negative 9. Then we'll square both sides so that x plus 4 equals 81, and then I'd subtract 4 to move it to the other side, so x equals 77. Now many times when you're solving a radical equation, you may need to check your answer, and I think this may be one of those times. So we're going to put 77 in for x here. So we have the square root of 77 plus 4, and then plus 2 equals negative 7. So 77 plus 4 is 81. We'll take the square root of 81 plus 2 equals negative 7. The square root of 81 is 9 plus 2 equals negative 7. So this actually gives us 11 equals a negative 7, which is not true. So this does not have a solution. Okay. Now, if this would have had a negative sign in front of it, then we would have been able to get a negative 7. But it did not, so we cannot say 11 is equal to negative 7. Okay, so sometimes we're going to come up with no solutions on these problems and we'll have to check our answers. Okay, on example 3, we're going to start the same way we did earlier and isolate the radical. So I'm going to add 3 to move it to the other side. So I'll have the square root of x minus 3 equals 8, and then I'll square both sides. So I'll have x minus 3 equals 64. Then I'll add 3, so x equals 67. Now again, let's go ahead and check ourselves. So I'll have the square root of 67 minus 3, and then a minus 3 on the outside of that equals 5. So I'll have the square root of 64 minus 3 equals 5. I'll have 8 minus 3 equals 5, and 5 does indeed equal 5, so this checks out and it's a good solution. Alright, let's look at the next problem, example 4. So again, we have a really long radical this time, but we still follow the same process. So I'm going to add 3 to the other side, and you'll notice this time we have an x over here, so that makes things just slightly more complicated. So I'm going to have the square root of x squared plus 2x plus 13 equals x plus 3. Then, now that I have my radical all by itself, I'm going to square both sides. So I have x squared plus 2x plus 13 equals, and this will be x squared plus 6x plus 9. And if you needed to, you could actually write that out, x plus 3 times x plus 3, and then multiply your x across, so you get x squared plus 3x, and then multiply the 3 across, so you get plus 3x plus 9, and then add your middle, and you'll get that same answer. Okay, and then after we do that, we need to move everything on one side of the equal sign. So I'm just going to move everything to the left side just as a habit. You could move everything to the right side, and in the end you would still get the same answers. So I'm going to subtract x squared, then I'm going to subtract the 6x, and I'm going to subtract the 9. So I'll have, my x squareds will cancel, I'll have a negative 4x plus 4 equals 0. And then I'm going to subtract the 4 and move it to the other side. So negative 4x equals a negative 4. Then I'll divide both sides by negative 4. So x equals 1. Okay, we're going to plug that back in for the x's and see if that works out. So I'll have the square root, also that x, of 1 squared plus 2 times 1 plus 13 minus 3 will equal 1. So I'll have 1 squared plus 2, so 1 plus 2 plus 13 minus 3 equals 1. I'll have the square root of 16 minus 3 equals 1. So 4 minus 3 equals 1, so 1 equals 1. So that does check out, it does work. So it is indeed a solution.